Welcome to the final pillar of object-oriented programming, abstraction. Abstraction is often considered the most important design principle. It is about simplifying complexity by showing only the necessary features to the user and hiding the complex, internal implementation details. You already practice abstraction every time you use a library function without needing to know how it works internally. 1. Definition of abstraction. Think of a car. You interact with the steering wheel, pedals, and gear selector, the essential interface. You don't need to know how the engine manages fuel injection or piston timing, the complex details. Abstraction separates the interface from the implementation. In Python, the primary goal is to define common interfaces and enforce that subclasses implement them. 2. Abstract classes in Python. Python uses a concept called abstract base classes, or ABCs, to implement abstraction. An abstract class is a class that contains one or more abstract methods. An abstract method is declared but does not contain any implementation. It only defines the required method signature. You cannot create an object directly from an abstract class. You must inherit from it. 3. The role of abstract methods. The purpose of an abstract class is to act as a blueprint or template. It defines a set of methods that all concrete subclasses must implement. For example, A-shape abstract class might define an abstract method, calculate _area. Any subclass, like circle or rectangle, is then forced to implement its own specific calculation logic for that method. 4. Interfaces, protocols. While abstract classes can have both abstract and concrete, implemented methods, an interface is a class where all methods are abstract. It defines a protocol or a contract. If a class implements an interface, it must implement all methods defined in that interface. We already saw this with duck typing, but now we will use Python's tools to formally enforce these contracts. To summarize, abstraction enforces structure and ensures specialized classes adhere to a standard interface. Our next lecture 20.02, Create an Abstract Class. See you there. Welcome back. To formally enforce abstraction in Python, we use the built-in ABC module, which stands for Abstract Base Classes. This module provides the necessary tools to declare a class as abstract and mark certain methods as abstract, thereby creating a contract that all subclasses must fulfill. 1. Defining the abstract base class. First, we import ABC and abstract method from the ABC module. To make a class abstract, it must inherit from ABC. We define a concrete method, load_date, which has an implementation. But we also define an abstract method, process_data, decorated with @abstract_method. This method has no logic and serves as a placeholder, enforcing that all children must define their own processing logic. 2. Rule 1. Cannot instantiate abstract class. The most fundamental rule of an abstract class is that you cannot create an object directly from it. If you try to instantiate data processor, Python immediately raises a type error. This ensures that the class remains a blueprint and forces developers to use only the complete, implemented subclasses. 3. Creating the concrete subclass. To use the blueprint, we create a concrete subclass, CSV processor, that inherits from data processor. To be a valid instantiable class, CSV processor must implement or override the abstract method process_data. 4. Rule 2. Testing the implementation and inheritance. We can successfully create an object of CSV processor. This object has both the inherited load_data method from the parent and its own specialized process_data method. This shows how abstract classes ensure a common structure while allowing for specialized implementation. To summarize, abstract classes provide a mix of common implementation and enforced specialization. Our next lecture 20.03, Create an Interface. See you there. Welcome back. In the last lecture, we created an abstract class that had both concrete and abstract methods. Today, we focus on a special case, creating an interface. In Python, an interface is simply an abstract base class where every method is abstract. It defines a contract that forces all implementing classes to provide their own specialized functionality. 1. Defining the payment interface. We import the necessary modules and define payment processor as our interface. Notice that both methods, process_payment and check_status, are decorated with @abstract method and have no implementation body. This class is purely a contract. Any class that uses this interface promises to implement both of these methods. 2. Implementing the interface. We create a concrete implementation, credit card processor, which inherits from our interface. It provides the specific internal logic for process_payment and check_status. By implementing all abstract methods, this class fulfills the contract and can now be instantiated and used. 3. The enforcement of the contract. If we create another processor like PayPal processor and forget to implement the check_status method, Python prevents us from creating an object of that class. The interpreter raises a type error at the moment of instantiation, warning us that the class is still abstract. The interface successfully enforced its contract. To summarize, interfaces define standard behaviors without dictating implementation, which is crucial for building large, flexible systems where many components need to be interchangeable. This completes our discussion of the 4 pillars of OOP. Okay, next we are going to the next section, section 21, our next lecture 21.01. Introduction. See you there.